Everyone. We will continue with our discussion on matrices right now. We will look into the multiplication of matrices right now. Let me open the whiteboard for you right now. Okay. The product, right? Let us assume that A is a matrix and B is a matrix. Okay. The product AB is possible only if the number of columns in A, right, is equal to the number of rows of matrix B. I repeat, the product AB is only possible if number of columns, right, columns of matrix A, right, is equal to number of rows of matrix B. Okay, this is the most important stuff we need to have it. For example, the order of the matrix A is given by M by N. Okay, and the order of the matrix is given B is given by N by P in this case. Okay, so AB is of the order M by P. Okay, this has to be taken care in this case. Number of columns is equal to the number of rows of another matrix in this case. So whereas like whether BA is possible in this case or not, BA is not able to define in this case. It's not able to define because for B the order is N by P, right? For A it is M by N. Okay, so this is not equal to this one, right? So BA is not defined in this case. So only AB is possible for this type of matrix. Okay, if it is a square matrix, then we can have AB as well as BA. For the square matrix only we have like that. For square matrix, we can multiply AB, A and B, and then B into A. Okay, but the results may not be always same in this case. Okay, we cannot expect AB is equal to BA in this case. It is not always same. Okay, this is the generic concept with respect to matrices. Okay. So how we can do this multiplication right now? Method of multiplying two matrices. Okay. The first and foremost step is like we need to find out whether the number of columns of the first matrix, let us assume A in this case, is equal to the number of rows of second matrix. Okay, then only we can say AB is defined in this case. Otherwise, AB is not able to define in this case. Okay, so if it is not this, the multiplication is not like when you are watching the question, it's like this, it is not satisfied, then we can clearly say AB is not able to define in this case. Okay, the number of columns of the first matrix is not equal to the number of rows of the second matrix, then we can say AB is not able to define. Okay, the product is not possible in this case. So it has to abide by this first rule number one in this case. Okay, rule number two, we need to multiply the first row, right, of multiply first row, that is R1, right, with the first column. This is R1 of A. Okay, column of is C1 of the other matrix B in this case. Okay, and take the sum of all this product. Assuming that the matrices are like A1, B1, C1. Okay, this is nothing but this A11, A12, A13, right? This is B11, B21, B23. Sorry, 31. So we need to have A1, 1, B1, 1. Okay, plus B12, B21 plus C13, B31. Okay, this is the first element of the product matrix in this case. Okay, so obviously what you have to do, multiply the first row. You have to take the first row in this case and then multiply with the first column. There each an element, right? This element has to be multiplied with this one, and this has to be multiplied with this one, and this has to be multiplied with this one, and then you need to add all those things, which gives the first element of the product matrix in this case. Okay, you need to repeat the process for each rows as well as each columns. So we can see this one with an example which will help you to understand more. For example, AB is given in this case. Okay, AB is equal to what? They want to know that in this case. If A is equal to 6923 and B is equal to 260798. These are the elements here in this case. First of all, we need to see what is this order in this case. Order is nothing but 2 by 2. This is again 2 by 3, right? So here number of columns in column matrix A is equal to the number of rows in the matrix B. So AB is possible right now. We can define AB in this case. The first rule we'll check it right now. If it is not means, then we have to say like the product is not possible in this case. Okay. Now product is possible right now. The second step, what is there in this case? We need to take the first row of this one and then multiply with the first column in this case, right? So AB, right? It has to be defined in this case. This is nothing but 6 into 2 plus 9 into 7. This is the first. Similarly, if you see there, what is second row? We need to take it in this case, right? 6 into 6 plus 9 into 9. Fine. Then third one is 0 into 6 plus 9 into 8. Okay. Similarly, you need to take the second row in this case and then multiply in the same way in this case. So 2 into 2 plus 3 into 7, 2 into 6 plus 3 into 9, 2 into 0 plus 3 into 8. So see, it's nothing but 12 plus, again you can have one more step, 12 plus 63, 36 plus 81, 0 plus 72. This is 4 plus, what is this, 3 into 7, 21. 4 plus 57 is nothing but 75, 110, 117, 72, 25, 39, and 24. This is the product matrix we have. Okay. See, one more information I just want to tell you right now. This is the product matrix AB. See, okay, I just want to tell one more point here. Okay, the order of the product matrix is always given by like this is the one you have to take it. It should be of the order 2 by 3. If 2 by 2 is matrix A, 2 by 3 is matrix B, right? This order means, so strike out this one, the order should be like 2 by 3 in this case. So see there the product also we can get 2 rows and then 3 columns in this case. That's how we need to do that. When you are working out, actually, we can just put out. You can put in. This is product AB is given by another matrix C in this case. Okay. So we can say C11. We can find out separately there. C12, C13, C21, C22, C2. We can put the steps and finally we can club it like that. Okay. I just work out one more problem there for you to understand better. What you have done right now here, you are just find the given values are of A, matrix A is given, matrix B is given, matrix A is of order 2 by 2 and matrix B is of order 2 by 3. So we need to find the product AB. AB is or possible or not. We have 2 steps here. First we need to find out whether the number of columns of the matrix, first matrix is equal to the number of rows of the second matrix. This is it's satisfying this equation right now, satisfying this condition right now. So we can move to the next step. We need to see like what is the order in this case. The product AB, right? It will be of the order 2 by 3. Just remember this one so that we'll have 6 elements as to come into picture here in this case. Okay. Now we are saying AB in this case, right? We are taking the first row and then first column. Just we are doing the multiplication of each and every elements there and then summing those elements in this case. Okay. Similarly, first row and second column in this case. This is also first row and third column in this case, right? Similarly, second row, first column, second row, second column, second row, and then third column in this case. So we are able to get the product here in this case. Fine. We'll work out one more problem here because multiplication is slightly complex in compared to addition or subtraction. Okay. See, one more question you can have it. Compute the product of 0 to 4, 3, 0, and 5. So let us assume this is matrix A and this is matrix B. Okay. You need to find out. This is a square matrix, right? Square matrix is it is of order 3 by 3. This is also of order 3 by 3. In this case, the first rule says that it's like number of columns, right, of the first matrix is equal to the number of rows of the second matrix. That is satisfied here. So the product is possible. Square matrix means we have both AB as well as BA is possible in this case, right? Fine, we have to find AB in this case, okay? So the resultant matrix, right, whatever is we are going to get it, right, it is also of the order 3 by 3 in this case. So order of the resultant matrix is also 3 by 3. So AB is equal to what? So we can say AB is equal to C. That is equal to what? So it is of order 3 by 3. That is only information we need to know right now. Okay. So we just see that what is C1 you can find out separately in this case. C1 is nothing but first row and then first column in this case. Okay. Multiply this one and then see 2 into 1 plus 3 into 0, 4 into 3. So what is the value in this case? 2 plus 3, 5 plus 12, 17. Similarly, C12 is nothing but first row and then second column in this case, right? 2 into 3 plus 3 into 2 plus 4 into 0. Okay. We can say 6 plus 6, 12 plus 2, 16. Okay. What is C13? So nothing but first row and then third column in this case, right? 2 into minus of 5 plus 3 into 4 plus 4 into 5. That is equal to this is minus 10, this is plus 12 plus 20. So equal to 22. Again, I see that this is 1 into order will be this is 22, right? This is fine. So we need to similarly find for C21, we'll see, we'll write it again. There are some problems with this tool right now. Let me wait for a minute. Okay, this is what the value right now, right? So 2, 3, 4, 3, 4, 5, 4, 5, 6. A. 1, 3 minus 5. Fine. Okay. I will write down again. This is A and B is given as we find this value of C11, C2, C23, right? So we need to find the value of C21 is equal to nothing but second row and then first column in this case, right? Second row and first column. That is nothing but 3 into 1 plus 4 into 0 plus 5 into 3. 3 plus 4, sorry, 0 plus 15, that is equal to 18. Similarly, C22, that is 3 into 3 plus 4 into 2 plus 5 into 0 equal to 9 plus 8 plus 0, 17. 3 to 3, 3 into minus 5 plus 4 into 4 plus 5 into 5. What we are doing right now, we are just multiplying this second row with the last column in this case, right? So minus 15 plus 16 plus 25 equal to 26. So T31 is equal to third row, we need to take it in this case. 4 into 1 plus 5 into 0 plus 6 into 3. 4 plus 18, 22. Okay. T32, 4 into 3 plus 5 into 2 plus 6 into 0. This is 12 plus 10, 22. And C33, nothing but 4 into minus 5 plus 5 into minus 5, 4 into minus 5 plus 5 into 4 in this case, right? 5 into 4 plus 6 into 5. This is 30, 20, 50 minus of 20. That is 30. So the product matrix AB is given by C11, C12, C13, C22, C, sorry, 21, 22, 23, 31, 32, 33. So we arrange those things in this order. What is the value in this case? Okay. I will write here. We know that CT2 here from this screen, we will say that 18, 17, 26 is the second row. The third row is 22, 22, and then 30. The first row will see that I think there are some problem with the tool right now. This is C1 is 17, 16, and 22, right? That's the first row column. Okay. I just want to add again 17, 16, and 22. So this is the product matrix AB. Fair enough. Fine. I just want to close this section because there are some problem with the tool right now. I will continue with the matrix multiplication in the upcoming session. Okay. Thank you. Thank you very much.